Welcome back to our next video. We've done all the lesson plans, we've taken you through all the various tools, but we've come back with a few other things that I found I needed. There have been some times that I didn't like this commercial parting tool for a particular project, and I've used my handmade tool, which is modified from a commercial hacksaw blade. And generally I use this thing for parting off the neck of a small vessel from a faceplate. Because it's narrow, I use it for splitting rings. I also use it for marking the base of a project, so I can see where the curve ends up. But there's a few times that it doesn't work, like for instance coring out a ring. The tool itself in this dimension here is just too tall. So I've used a commercial tool, as you can see in the video. But I want to make my own. So I'm going to show you two parting tools that I make. One is a little bit more complicated, you can do it. And the other one is really, really simple. I'm going to save the easy one for the end, as you would expect. So the first thing I did was to make one out of 01 high-speed steel. This is a tool steel material. I purchased it from the local machine tool supplier. In this case, I use MSC, and this is called Starrett. It's a brand name. It's 01, which means oil hardening tool steel. So I'm going to actually finish making this tool. First thing I've got to do is to cut the blank, grind it to shape, and then heat treat it. So here is the steps that I go through to make this tool. Okay, we're at the heat treating station. Let me show you what I've got. This is the kiln I built several years ago. It's basically a tin can, and I lined it with 1 part play sand, 1 part plaster Paris, 1 part water, and that's all the refractory that is. Now, it breaks down over time, but it'll be okay. Here I have some peanut oil because I need to heat the tool to what's called the decalescence point, where the crystalline structure of steel changes, and then freeze it real quick by sticking it into oil. Here's my tool. Here's a way of holding it. I'm just going to grab it in a pair of these long nose vice grips, so I've got a way of holding it without getting my fingers hot. My heat source is going to be MAP gas. I could have used propene. I just chose to use MAP gas. It's a little hotter, so the process moves a little bit more rapidly. I have a fire suppressant here if I need it. It's always at hand. I'm working at a welding bench, so these are fire bricks set into steel frames, so there's nothing here that's going to burn. The last thing and the most important thing, and this is not my preferred one, but this will work. This is a magnet. At the decalescence point of steel, when it reaches that point, if I touch it with a magnet, it becomes non-magnetic. This will not stick. And that's the way I know when I reached exactly the right temperature point. At that point, into the oil, and we have it heat treated, and the hardness on this O1 will be someplace between 55 and 60 Rockwell. There's one last step which I'll do after I get home, and I won't do it here on camera. But in that last step, what I'm going to do is to take this, clean it a little bit, get all the goop off of it, and then I'm going to put it in my oven at home at 400 degrees for 1 hour, and then turn the oven off and allow the temperature to slowly come back down to room temperature. What that does is take a little bit of the brittleness out of the hardness, and so it stays hard, loosens a little bit, and there's a program for that. But what happens is it becomes much less brittle, and the edge is going to hold longer. So I'm going to temper it back, and that's called tempering. So here's the process. Let's go do it. MAP gas, there's a hole in the back of my origins to go in. And now we're just processing it. What I'm trying to do is to heat it up uniformly. I don't need the tang heat treated. In fact, I like it to stay soft because it becomes more flexible, less apt to break. And I'm going to turn it over and do it from both sides. Now I'm looking down into the furnace, and I'm able to watch the color development. You may not be able to see it. Right now it's just barely beginning to become very slightly pink. In fact, you might imagine that it hasn't, but it's turning pink. And slowly it's becoming red. I can see red developing now. It's a dark cherry. I'm going to pull it out of here so you can see what it looks like. No, you can't. You lose the color. It's in here. It's dark, and that helps. And I'm moving it back and forth through the flame. And it's still cherry, but it's becoming a very light cherry color. And to reach a point, I can tell by eye that the redness is almost translucent. I don't know if I can describe that any other way. But the dark red is getting lighter. And I want to make sure the very tip is at the temperature we want. And now I'm going to test it with a magnet. Still slightly magnetic, so I'm not quite there yet. Thicker tools take longer, obviously. Not magnetic. And I'm moving it around so that we get the cooler oil always coming in contact with the surface. Turn my torch off so I can talk quieter. And you can see what's happened. The thing is discolored. It has a bluish straw color coming back here, which means the heat is transferred back part of the way. You can see it on the tang. The heat lines coming back here, and where I'm holding on to has never gotten hot. So this has to cool, then it has to get cleaned up. And after it's been cleaned up, then I'm going to put it in the oven at home and heat treat it at 400 for an hour. And this is ready for a handle. You can build one of these ovens very easily. Everything I needed for this, I got at Home Depot. I went to the paint department, found that, bolts, handle, play sand, plaster of Paris. I provided my own water. And the MAP gas head stays here, and this is where we heat treat all of our tools.
Right.
We got almost all the steps of doing that. The one thing that's left is I have to clean up the surface. I buff it up a little bit so it looks nice, get that oil off of the surface, and maybe put a handle on it. You've seen how to do that. That's an earlier video we've already done. But you've been waiting for the easy one, which I'm going to show you now. Same industrial supplier. I went to my MSC or any other source, and I bought some industrial hacksaw blades. Sort of like the ones we used before, but just a little smaller. These are narrower, they're thinner. So I'm going to take this hacksaw blade and I'm going to convert it into a parting tool. So the first thing I needed to do was literally to take the powdered metal coating off of both sides of this blank, because as I use it in cutting into the wood, it will tend to bind a little bit. So I've simply gone to a belt sander and polished that surface off. Now I'm going to take this, I'm going to go to our standard bench grinder, I'm going to convert it into this. What I'm going to do is take the teeth off, and I'm going to grind this shape into it. This is high-speed steel. It needs no treating, and it's ready to go. And to resharpen, I'll show you how that's done also. So this is a handled tool, ready to go, and it cost me approximately $15 material cost and a few minutes worth of labor. So let's show you the few minutes worth of labor next. I'm going to go with the grinder and complete the project and make this tool. We're at the grinder. I'm going to process this hacksaw blade. I've reset the platform. It's very slightly above horizontal. I don't want it to be horizontal because I don't want to catch this and pull it in. Also, I see the teeth, I'll say it correctly, the teeth face this direction. So as I process to cut the teeth off, I'm going to go with that flow. Otherwise, it's like rubbing a cat backwards. Since I'm going to be grinding here and I'll pull off some aluminum oxide flakes, I'm going to also have my dust mask on. So, first step, take these off. Second step will be to create the curve on the end. And before I get that, I'm going to go get some water here so I can dunk this as I begin to grind the actual shape on it. So, let's get the teeth off first. Dust mask, face shield, not face shield, but glasses. Okay, we got the teeth ground off. My last couple of passes there were simply take off any burrs that might have occurred to that edge. High-speed steel, but they're small, thin piece of metal, so it doesn't take very long to get these things ground down. So now I'm going to shape the tip. I'm going to grind this curve in here. I'll stop my grinder because I'm going to reset the platform up to an angle so I can use the platform here. And this is somewhat arbitrary. Yeah, that's about right. Lock this down. I'm going to step out of the camera for a second and go fill this with some water. Be right back. Okay, now I've got some water. This is simply so I don't get my hands warm. I don't want to overheat the high-speed steel, but I won't lose its temper. It is pre-tensiled already for cutting. I just don't want to get my hands too warm. So now let's put an edge on it. So I ground enough to come back beyond that hole. That was the whole reason for grinding so much metal away. And it matches the curvature of the wheel, and that's exactly what we've always done. This is the cutting edge in this posture here. So when I need to sharpen it, it's go to the grinder and touch that edge. That's it. That's all it takes. But now I have something less than a 1/16 inch thick and about 1.25 inches tall, and that's going to fit into some places that other tools haven't. And look at this, it comes complete with a built-in handle, all set to go. So today I've shown you two new parting tools. This one, which is a little bit more complex, but fun to do, and does require a little processing by cutting out the shapes. I'm not picking this up. To cut that shape out, I need a bandsaw, or a hacksaw would do it. And I've showed you a simpler way, which is the way with using the hacksaw blade, grinding the teeth off, grinding the curvature into it. Took minutes to do. So stay tuned, subscribe, come back and see what we do for you next time. Take care.